In 1948, a 30-year-old test pilot named Glenn Edwards climbed into the cockpit of a Northrop YB-49 at Muroc Army Airfield in California. The aircraft looked like nothing else in the sky. No fuselage, no tail, 4 jet engines buried inside the wing itself. On paper, it was the most aerodynamically efficient bomber ever conceived. Longer range, less drag, more payload than any conventional design. 15 minutes into the flight, the YB-49 entered a stall it never recovered from. Edwards and 4 other crew members were killed. Within a year, the entire flying wing program was cancelled. The airbase was later renamed in Edwards' honor. Geometry, the industry decided, always wins. For nearly 80 years since, commercial aviation has accepted a settled truth. The tube and wing layout is simply how airliners are built. A pressurized cylinder for people and cargo, swept wings that carry the load, a tail at the back, engines slung below. Every single aisle, every wide-body, every ULR long-haul aircraft manufactured today is a variation on the same architecture Boeing and Douglas locked in during the 1960s, refined constantly, rethought almost never. In August 2023, a California startup called JetZero secured a $235 million contract from the United States Air Force to build a full-scale demonstrator of a shape the industry buried in 1949. That company is now 4 years old. It has raised over $1 billion in total commitments. It has broken ground on an 8 million square foot factory in North Carolina, and it has letters of intent or investment from United, Alaska, Delta, Japan Airlines, and Gulf Air. But here's the problem. JetZero has never delivered an aircraft. It has no certified product. Boeing and Airbus each spend more on annual research than JetZero has raised in total. A single clean sheet program at either manufacturer typically consumes $30 to $40 billion before first delivery. Yet the US Air Force, Northrop Grumman, RTX, 6 major airlines, and a possible $3 billion Exim Bank credit line are all now attached to this company. So how does a startup with roughly $1 billion threaten a duopoly built on trillions? To understand why JetZero matters, we first need to understand why the shape it's chosen was written off in the first place. A conventional airliner is aerodynamically a compromise. The cylindrical fuselage is structurally excellent for pressurization. A tube distributes cabin pressure loads evenly around its circumference, but aerodynamically, that tube is dead weight. It produces drag without contributing lift. The wings do all the lifting work. Every increase in passenger capacity meant a bigger tube. A bigger tube meant more drag. More drag meant more fuel. Every gain came with an aerodynamic penalty baked into the geometry itself. Boeing and Airbus responded by optimizing the edges, better engines, composite structures, refined wingtips, cleaner fuselage seams. Each new program delivered fuel burn improvements in the low to mid-teens over the aircraft it replaced. Meaningful, never transformative, and a clean sheet aircraft is an existential risk. The 787 was nearly a decade late. The A380 never repaid its investment. Both manufacturers learned to prefer evolution over revolution. The A320neo, the 737 MAX, the A321XLR, safer bets than a radical new architecture. But that conservatism left a hole in the market. The space the Boeing 757 and 767 once occupied has only been partially filled. Airlines have been asking for a proper middle-of-the-market aircraft for over a decade. Nobody has built one, which is exactly the gap JetZero is aiming at. The Z4 is not a conventional aircraft with unconventional details. It is a fundamentally different architecture. The fuselage and wings merge into a single wide lifting surface. Instead of a tube dragging behind the wings, the entire aircraft contributes to lift. Every square meter of the airframe does aerodynamic work. The design targets 250 passengers over roughly 5,000 nautical miles. It's sized deliberately between the A321XLR and the 787. It runs on conventional jet fuel and standard sustainable aviation fuel blends. It fits inside existing airport gates, taxiways, and jet bridges without infrastructure changes. That last point matters more than it sounds. Every airport in the world would need to spend billions to accommodate a truly novel aircraft footprint. JetZero engineered around that problem before it existed. JetZero claims that it will have a 50% fuel burn reduction per passenger mile. Read that back. Boeing and Airbus measure new program improvements in single digits, a few percent from engines, a few from aerodynamics, a few from lighter materials. JetZero is claiming a step change of the kind aviation has not delivered since the transition from turboprop to jet. Fuel is the largest controllable cost in most airline operations, emissions regulations across Europe and increasingly Asia are hardening, sustainable aviation fuel remains expensive and supply constrained, hydrogen aircraft are still decades from mainstream service. JetZero's pitch is unusually pragmatic: conventional fuel, existing infrastructure, no unproven propulsion. The aircraft itself is radical, the business case around it is deliberately conservative. That combination is what turned an aerospace concept into a commercial program. The receipts arrived quickly. In August 2023, the US Air Force awarded JetZero its $235 million demonstrator contract. That funding bridges the gap where most aerospace startups die, the space between concept and first full-scale prototype. In April 2025, United Airlines invested through United Airlines Ventures with a conditional path to purchase up to 200 aircraft. In January 2026, JetZero closed a $175 million Series B led by B Capital, with participation from United, RTX Ventures, and Northrop Grumman. Then Farnborough, July 2026, changed the picture again. On the 21st of July, Gulf Air signed a letter of intent for an undisclosed number of Z4 aircraft with preferential delivery positions in the early 2030s, the first customer commitment from outside the United States. On the same day, Japan Airlines announced formal support for the Z4 program, contributing operational input on flight ops, cabin, and maintenance. Alaska Airlines is already an early round investor. Delta is a design partner through its Sustainable Skies Lab. But the most telling backer isn't an airline, it's Northrop Grumman. Scaled Composites, the company physically building the Jet 1 demonstrator in Mojave, is a Northrop Grumman subsidiary. Northrop is the direct corporate descendant of the company whose flying wing killed Glenn Edwards in 1948. The company that failed to make this shape work 78 years ago is now the company betting it finally will. JetZero is not just an airframe, it's an emerging industrial system. The company's Long Beach headquarters spans 7 buildings and 285,000 square feet. Its Jet 1 production runs out of Scaled Composites in Mojave. In June 2026, the company broke ground on its Greensboro, North Carolina manufacturing campus, an 8 million square foot facility that at full capacity aims to produce up to 20 Z4 aircraft per month. It's the largest single job announcement in North Carolina history, with a target of over 14,500 positions by 2036. JetZero has also opened a satellite engineering office at Wichita State University's National Institute for Aviation Research, plugging directly into America's densest concentration of aerospace engineering talent. Behind all of that sits the Pathfinder program. 5 generations of scaled aircraft, over 30 test flights, validating configuration and control laws before the full-scale Jet 1 has flown. The board now includes Pat Shanahan, former acting U.S. Secretary of Defense and a former Boeing executive. The Export-Import Bank has signed a letter of intent to explore up to $3 billion in financing for the Greensboro campus. Long Beach designs it, Wichita engineers it, Mojave builds it, Greensboro will manufacture it. The Pentagon underwrites the demonstrator. 6 airlines are already at the table. No single asset here threatens Boeing and Airbus, but the system, quietly, does. Everything so far is the case for JetZero. Now the case against it. The blended wing body doesn't achieve its efficiency by flying higher, but through its shape. By blending the fuselage and wings into a single lifting surface, the entire aircraft generates lift while producing far less drag than a conventional tube and wing design. Flying at higher cruise altitudes further reduces aerodynamic drag, but modern airliners like the Boeing 787 and Airbus A350 already cruise above 40,000 feet. Altitude isn't the breakthrough, the airframe is. To get the Jet 1 demonstrator into the air, JetZero chose the Pratt & Whitney PW2040, a proven engine from the PW2000 family that first entered airline service on the Boeing 757 in the mid-1980s. JetZero selected it because it's reliable, readily available, and already certified, not because it represents the aircraft's ultimate production power plant. The PW2040 burns roughly 25% more fuel than a modern engine like the GE9X, which means the demonstrator physically cannot hit the 50% fuel burn target JetZero markets. That number depends on eventually pairing the BWB airframe with a modern, high-altitude optimized engine that hasn't been developed for commercial application yet. If real-world performance lands at 25 to 30% better than conventional aircraft, still remarkable, the Z4 is compelling. It is not transformational, and airlines don't accept the risk of a new manufacturer for incremental gains. Designing a novel aircraft is hard. Producing one at scale is much, much harder. Mitsubishi spent 12 years and roughly $10 billion on the SpaceJet before canceling without delivering a single passenger aircraft. Boom Supersonic has faced repeated delays and is now developing the Symphony engine with partners. Comac's C919 took over a decade to reach limited commercial service, and only within the Chinese market. Production at commercial scale requires supplier ecosystems that take years to build. It requires quality control systems that cannot fail. It requires cash to survive years of negative returns. Even Boeing and Airbus, with decades of institutional muscle memory, are struggling to deliver aircraft on schedule right now. JetZero has partnered with Scaled Composites, an experienced specialist, but Scaled has never built a passenger aircraft either. Building 20 airliners a month in Greensboro is not the same challenge as delivering a single demonstrator in Mojave. It is a different company with different problems. The gap between one prototype and a functioning production line is the graveyard of aerospace startups. Then there's the aircraft passengers will actually experience. The Z4 cabin is wide, multiple aisles, vertical interior walls. But because the fuselage is the wing, most passengers will not sit near a window. JetZero plans to use digital displays and forward skylights to compensate. Whether passengers accept a simulated view remains genuinely unknown. Motion dynamics differ too. Passengers seated far from the aircraft's center of gravity will feel banking and turbulence differently. Some seats could feel disorienting. And there is the regulator. The FAA and EASA have decades of certification precedent for tube and wing aircraft. A BWB creates novel questions. Cabin pressure loads in a non-cylindrical shell, engine-out behavior with engines mounted above and behind the fuselage, and the 90-second evacuation standard against a wide, short cabin with unusual exit geometry. Post-737 MAX, regulators are more cautious, not less. The Z4 will be certified only if every novel feature can be proven to meet an equivalent level of safety. None of these obstacles is insurmountable. All of them are unresolved. Boeing isn't going anywhere. Neither is Airbus. Between them, they have order backlogs stretching into the 2030s, production networks measured in continents, and certification relationships that no startup can replicate quickly. But the settled assumption that tube and wing was permanent, that clean sheet architectures were commercially impossible, that only the duopoly could build the next great airliner, is now definitively over. Because here's what actually matters about JetZero. The company doesn't need to become the next Boeing to change the industry. It just needs to prove the blended wing body works as a commercial product. If the Jet 1 demonstrator flies in 2027 and validates even most of the aerodynamic claims, the strategic map redraws. Every other manufacturer has to decide, quickly, whether to respond or cede the middle of the market to an outsider. Airbus has already tested a BWB scale demonstrator called Maverick. Boeing has explored the concept through NASA partnerships going back 2 decades. Neither has committed to a commercial program. They now have less time to decide than they did a year ago. Because United isn't waiting, Alaska isn't waiting. Delta, Gulf Air, and Japan Airlines are all now formally engaged with a company whose demonstrator is still 18 months from its first flight. That response, from 6 major carriers, from Northrop Grumman, from the Pentagon, from XM, is itself the proof. The industry is already taking JetZero seriously, whether or not the Z4 ever enters service. 250 seats, up to 50% less fuel per passenger mile, roughly $1 billion in committed funding against a duopoly worth hundreds of billions, and proof that sometimes the most significant shifts in aviation don't come from the manufacturers with the biggest balance sheets. Sometimes they come from a startup with the conviction to bet on a shape the industry buried 78 years ago, and the discipline to make the business case around it look boringly conservative. The YB-49 was ahead of its era. JetZero arguably is on time. The question isn't whether one startup can change the shape of aviation. It's whether Boeing and Airbus have really been paying attention.